Question number 1. Question number 2. Question number 3. Question number 4. Question number 5. This is homework for you. Question number 6. This is also homework for you.
Good morning, students. In today's class, we are going to solve the numericals from the chapter that is dual nature of radiation and matter. Before starting the numericals, let me recollect the list of formulae which helps to solve the numericals. The first one is energy of incident radiation. If you want to find the energy of incident radiation or the energy of the photon, we have to use the formula energy is equal to h nu, or else energy is equal to hc by lambda. E is equal to h nu. This is in terms of the frequency of the radiation. E is equal to hc by lambda. This is in terms of the wavelength of the radiation, where h is a Planck's constant. H is what? Planck's constant. That is nearly 6.623, and you can make this one as a 6.63 into 10 to the power minus 34 joule second. Next, c is the speed of the light. That is a 3 into 10 to the power 8 meter per second. Nu is what? Frequency of the incident radiation. Lambda is the wavelength of the incident radiation. This is about the first formula is about the energy of the incident radiation. If they have given the frequency, use this formula. If they have given the wavelength, use this formula. If they give the wavelength, we have to use the formula hc by lambda. C is what? Speed of the light. And remember the Planck's constant value, that is 6.63 into 10 to the power minus 34 joule second. Next, work function. Work function is equal to what? H nu naught. In the same way, here energy is expressed in terms of the frequency as well as the wavelength. In this case also, we are expressing the work function in terms of the frequency and also in terms of the wavelength. Here work function is equal to h nu naught. Nu naught is what? Threshold frequency. Lambda naught is what? Threshold wavelength. H is what? Planck's constant. C is what? Speed of the light. Means if they have given the nu naught value, we have to use the first equation, that is work function is equal to h nu naught. If they give the threshold frequency, if you want to find out the work function, we have to use work function is equal to h nu naught. If they have given the lambda naught, that is the threshold wavelength, if you want to calculate the work function, we have to use the equation hc by lambda naught. Nu naught is the threshold frequency, lambda naught is the threshold wavelength. This is about the equation work function. Next, important equation, that is Einstein photoelectric equation. What is that one? Total energy is equals to work function plus maximum kinetic energy of the emitted electron. Energy is equals to what? H nu. Here already have one. Energy is equals to h nu, or else you can take the energy is equals to hc by lambda. Work function is equals to what? H nu naught, or else you can take hc by lambda naught also. Kinetic energy. Kinetic energy is given by what? Half m v square. M is what? Mass of the photo electron. That is nothing but mass of the electron emitted from the metal surface. V max is what? Maximum speed of the electron emitted from the metal surface. When the electron comes out of the metal surface, it will have certain speed. To determine that one, we have to use, that is kinetic energy is equal to half m v square. By using this equation, kinetic energy is equal to half m v square. If you know the V max, you can calculate the kinetic energy, or else when you know the kinetic energy, you can calculate the speed. That is, speed is equal to what it will be? 2 into kE divided by mass. That is v square, we will get V is equal to what it will be? Square root of 2 kV divided by m. That is, just remember this equation. Kinetic energy is equal to half m V square. Total energy is equal to work function plus kinetic energy. Work function is given in terms of the frequency as well as wavelength. Energy is also given in terms of the frequency, also in terms of the wavelength. Next one, that is electron volt. Electron volt is the practical unit of the energy. It is not the SI unit of the energy or not the SI unit of the work function. When you want to convert the quantity in terms of the SI unit, we have to use 1 electron volt is equal to what? 1.6 into 10 to the power minus 19 joule. If you want to convert the work function or else energy from electron volt to joule, just you have to multiply that value with a value of 1.6 into 10 to the power minus 19 joule. If they have given the work function in terms of the electron volt, if you want to convert into joule, just you have to multiply with 1.6 into 10 to the power minus 19 joule. Next, if you want to convert joule to electron volt, what you have to do? Yes, you want to get the answer in terms of the electron volt only. What you have to do? Then you have to divide the value with the 1.6 into 10 to the power minus 19. Means that when you are going to convert from electron volt to joule, multiply with charge of the electron, that is 1.6 into 10 to the power minus 19 volt. If you want to convert from joule to electron volt, you have to divide with the value, that is 1.6 into 10 to the power minus 19. That is, here you are going to multiply with the value of the charge of the electron. Here you are going to divide with the value of the charge of the electron. Just remember that point. Energy, work function, Einstein photoelectric equation along with the kinetic energy. And one more formula is that is about the stopping potential. Can you tell me what is the equation for the stopping potential? Stopping potential is given by V naught is equals to kinetic energy divided by the charge of the electron. Stopping potential is indicated by the symbol V naught. Here, if it is a small v, if you use a small v, that is indicating the speed. If you use the capital V, or V naught, that is indicating the stopping potential. K is the kinetic energy. E is what? Charge of the electron. First numerical, just all of you read the first numerical. Yes, what they have given? The work function of cesium metal is 2.14 electron volt. When a light of frequency 6 into 10 to the power 14 hertz is incident on the metal surface, the photo emission occurs. Then what you have to calculate? Find first one A, energy of the incident photon. Next, second one B, maximum maximum kinetic energy of the photoelectrons. What they have given? Planck's constant H is equals to 6.63 into 10 to the power minus 34 joule second, and also 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. This question is from the theory exam, that is July 2014. Now, from the given question, we have to take the given data. What they have given initially? Work function. Work function is equals to what? 2.14 electron volt. Next, they have given the frequency of the incident light, that is nu is equals to 6 into 10 to the power 14 hertz. Along with they have given the Planck's constant, that is H is equals to 6.63 into 10 to the power minus 34 joule second. And also 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. First, what you have to calculate? A is nothing but energy of the incident photon. We have to calculate the energy of the incident photon. What is the formula to determine the energy of the incident radiation or energy of the incident photon? E is equals to what? H nu. H is what? Planck's constant. H is what? Planck's constant. Nu is what? Frequency of the photon, or frequency of the incident light. 6.63 into 10 to the power minus 34 into frequency. What is the frequency in the argument? 6 into 10 to the power 14. Now 6.63 into 6. Just you calculate this one. 6.63 into 6. That is equals to 6.63 into 6. Can you tell me the value? What is that value? 6.63 into 6 is equals to 39.78. 39.78 into, just calculate the powers. 10 to the power minus 34 into 10 to the power 14. That is 10 to the power minus 34 plus 14. Now 39.78 into minus 34 plus 14. What is the value? 10 to the power minus 20. This is the energy of the incident photon. Is it in terms of joule or electron volt? Here, Planck's constant they have given in terms of what? Joule second, that is SI electronic. Frequency, that is also SI electronic. So that the energy also will be in terms of the joule. Next, A is over. Next, what we have to calculate? The second one is the B. That is, we have to calculate the maximum kinetic energy. What we have to calculate? Maximum kinetic energy of the photoelectron. Then, is there any formula to calculate the kinetic energy? To calculate the kinetic energy, you may think that we can use the half m v square. Yes, mass m is the mass of the photoelectron, v is the speed of the photoelectron. Have they given the v here? If you observe the speed, have they given the v here? No, they didn't give. Then, which equation helps to solve this one? That is, we know the Einstein photoelectric equation. What is the one? Energy, total energy is equals to work function plus maximum kinetic energy. Is it right? Maximum kinetic energy. From this one we can make. That is maximum kinetic energy. If you take the work function, just what it will be? Energy minus work function is equals to maximum kinetic energy. Is it right? Yes. Now kinetic energy is equals to maximum kinetic energy of the photoelectron is equals to energy minus work function. Now we know the energy value as well as they have given the work function. Observe the work function. Have they given the in terms of the SI unit? No, they have given in terms of the electron volt. But here energy is in terms of the joule. Means that now we have to convert work function in terms of the joule. How to convert electron volt into joule? Already I said that one electron volt is equals to what? 1.6 into 10 to the power minus 19. Now work function is equals to 2.14 electron volt is into 1.6 into 10 to the power 1.6 into 10 to the power minus 19. Now 2.14 into 1.6. 2.14 into 1.6, that is 3.42. 3.42 into 10 to the power minus 19 joule. Now we got the work function in terms of the joule. Substitute these two. That is energy of the incident photon is equal to 39.78 into 10 to the power minus 19 minus work function value 3.42 into 10 to the power minus I think energy value. What is energy value? 39.78 into 10 to the power minus 90 or minus 20. That is minus 20. Next work function is equal to what? 3.22 into 10 to the power minus 19. Now here observe this one. Here the power is what? 10 to the power minus 20. Here the power is what? 10 to the power minus 19. Directly you cannot subtract. So that first we have to make the two terms in the same power. Here 10 to the power minus 19 is there. You convert this one also in terms of the minus 19. If you reduce the 10 to the power minus 1 means that is the term will be 3.978 into 10 to the power minus 19 minus 3.42 into 10 to the power minus 19. Now take the 10 to the power minus 19 as the common. This is the common thing. 10 to the power minus 19. It is the remaining thing 3.978 4. Calculate this one and write the kinetic energy in terms of the joule. That is 3.978 minus 0.42. Your value is about 0.0554 into 10 to the power minus 90. This is the maximum kinetic energy of the photoelectron emitted from the metal surface. They have given the work function along with the frequency of the incident light. What you have to calculate? Energy of the incident photon. If you want to calculate the energy of the incident photon, what is the formula? E is equals to h nu. Just we have substituted the h value as well as the frequency value. We got the energy value, that is 39.78 into 10 to the power minus 20 joules. Next one, B. Next one, what we have to calculate? Maximum kinetic energy. We know the Einstein photoelectric equation. Energy is equals to work function plus kinetic energy. From this one, kinetic energy will be equals to what? Energy minus work function. We have taken this work function LHS. Then the equation become energy minus work function is equals to kinetic energy. That is kinetic energy is equals to energy minus work function. Substitute the energy value as well as work function value. Here energy value is in terms of the joule, so that the work function also must be in terms of the joule. So that here we have converted work function from electron volt to joule. Just multiplying by value of 1.6 into 10 to the power minus 19. Now here we have substituted the work function value and also energy value. Here 10 to the power minus 20 is there, 10 to the power minus 19 is there. So that we made we have taken this one in terms of the minus 19. The electron becomes 3.978 into 10 to the power minus 19 minus 3.4 into 10 to the power minus 19. Here 10 to the power minus 19 is the common thing. Then the remaining value will be equals to 0.554 into 10 to the power minus 19 joule. This is the kinetic energy of the photoelectron. This is the energy of the incident light. Now the second numerical. Our period is second numerical. Yes. What they have given? Light of wavelength 4800 angstrom is incident on a surface of a photosensitive material of work function 1.05 electron volt. What we have to calculate? Calculate the energy of the incident photon. We have to calculate the energy of the incident photon. Second one, calculate the maximum kinetic energy of the photoelectron. This question is similar to the previous question, but the previous question is in terms of the frequency, but this question is in terms of the wavelength. They have given the wavelength of the incident light, that is 4800 angstrom, and also they have given the work function of the metal, that is work function is equal to 1.05 electron volt. What we have to calculate? Energy of the incident, that is the first one. Second one, we have to calculate the maximum kinetic energy of the photoelectron. Now here they have given the wavelength in terms of the angstrom. What is the extent of wavelength? Meter. Now we have to convert this one in terms of the meter. That is 4800. 1 angstrom means what? 10 to the power minus 10 meter. 1 angstrom is equal to 10 to the power minus 10 meter. Here also they have given work function is in terms of electron volt. Convert this one in terms of the joule. Already I said that one in the previous problem. 1.05 into 1.6 into 10 to the power minus 19. That is equals to what? 1.6 into 1.05. That is 1.68. That is equals to what? 1.68 into 10 to the power minus 19 joule. To solve the numericals in the theory examination, simple calculators are allowed. Not in the competitive examination. I am saying that the numericals in the theory exam only. Simple calculators are allowed. So while solving the theory numericals, if a simplification is there, we can go for it. We can use the normal calculator but not the scientific calculator. Now, work function is equal to 1.68 into 10 to the power minus 19. First, we will calculate the first one, that is energy of the incident photon. Energy is equal to what? H nu. What is H value? That is 6.63. 6.63 into 10 to the power minus 34. That is the Planck's constant. That is a known value. Frequency. Have they given the frequency value? Here we have taken the frequency. Have they given the frequency value? No, they have given the value. Then is it right to use this formula? No. What we have to use? We have to use the equation in terms of what? hc by lambda. hc by lambda. Now c is what? Speed of the light. What is the value of the speed of the light? It is 3 into 10 to the power 8 meter per second. Now write the unit. Next, lambda. Are they given the lambda? Yes. 4800 into 10 to the power minus 10. Here, first calculate the 6.63 into 3. What have we calculated? 6.63 into 3. Later, whatever the value you will get here, divide the value with the 4800. First, you calculate 6.63 into 3. Later, divide it by 4800. You will get the value nearly equals to 0.004143 into. Now we have to calculate the powers. Just we have calculated 6.63 into 3 divided by 4800. What about the powers? 10 to the power minus 34 plus 8. If you take this one to the numerator, what it will be? Plus 10. Negative power will become positive power when you take this one to the numerator. Now, energy is equals to. Shall I write here except only? Yes. 0.004143 into 10 to the power minus 34 plus 8 plus 10. That is 10 plus 8 is what? 18. Minus 34 plus 18. What is the remaining thing? S. Write the value here. Next, what we have to calculate? Maximum kinetic energy of the photoelectron. We have to calculate the maximum kinetic energy of the photoelectron. How to calculate the maximum kinetic energy of the photoelectron? Have they given the any speed value? No. Now we have to use the again same thing, that is energy value as well as work function. No, Einstein photoelectric equation. What is the one? Energy is equals to work function plus kinetic energy. Now from this one, kinetic energy is equals to energy minus work function. Energy minus work function. Now substitute the energy value, whatever you got here, and substitute the work function value, whatever we got here. Later you will get the value of the kinetic energy. Can you solve this one? Just you have to simplify the numerical. What you have to substitute? Energy value you have to substitute. Whatever the value you got here. Whatever the value you got here. Have you written this value? Minus 34 plus 18. What is the remaining thing? Yes. Later you calculate this one. Maximum kinetic energy. How to calculate the maximum kinetic energy? Energy minus work function. Substitute the energy value, substitute the energy value, and substitute the work function value, that is which is in terms of the joule. Now you will get the final kinetic energy is equals to what? I will give the answer. You simplify that one. The final value is about 2.46. 2.46 into 10 to the power minus 19. This is the maximum kinetic energy value. You simplify that one. Just we have followed the same process what we have done in the previous numerical. The previous numerical was about the frequency, but this numerical is about the wavelength. Just the same method we have followed. First we have calculated the energy. Later we have calculated the maximum kinetic energy. Here just you have to follow the simplification. You will get the value nearly 2.46 into 10 to the power minus 19 joule. Next we will move to the third numerical. Now the next numerical is number 3. Question number 3. I'll repeat the question. Light of a frequency 8.41 into 10 to the power 14 Hertz is incident on a metal surface. Frequency of the incident light is, they have given. Electrons with the maximum speed of 7.5 into 10 to the power 5 meters per second are ejected from the surface. When the light falls on the metal surface, electrons absorb the energy and they will come out of the metal surface with a speed of Vmax is equal to 7.5 into 10 to the power 5 meter per second. Then what we have to calculate? First we will calculate the work function of the metal in terms of the electron volt. First we have to calculate the work function in electron volt to make that one as a A. Next one, what we have to calculate? Calculate the threshold frequency of the photon emission of electron. What we have to calculate? Threshold frequency we have to calculate. And also they have given the Planck's constant. What is the value? 6.625. Or else you can make that is nearly 6.63 joule second. And mass of the electron 9.1 into 10 to the power of minus 31 kg. What they have given? Mass of the electron also they have given. Mass of the electron is 9.1 into 10 to the power of minus 31 kg. Now we are going to solve the numerical. That is first work function we will calculate. The two in terms of the electron volt. If you get the answer in terms of the joule, just you calculate the one in terms of the electron volt. Later we will calculate the threshold frequency. Now we know the basic relation between work function and threshold frequency. Work function is equal to what? H nu naught. Now they did give the nu naught value. We have to calculate the nu naught as well as work function. We have to calculate these two things. Means you cannot use this formula. Is it possible to use this formula? No. Why? Because when you know any one value, then only you can calculate another value. But when you do these two, we have to calculate these two only. You cannot use this formula. Now, what formula we have to use? We know the Einstein photoelectric equation. What is the equation? First, what we are going to calculate? Work function. I will drop this one. Work function. What we will calculate? Work function. Work function is equals to energy minus kinetic energy. Is it right? Directly I have written this formula. Since energy is equals to work function, energy is equals to work function plus kinetic energy. Here kinetic energy is equals to what? Energy minus work function, or else work function is equals to what? Energy minus kinetic energy. If you take this kinetic energy, then just what it will be? Minus kinetic energy. Energy minus kinetic energy is equals to what? Work function. Now, if you want to calculate the work function, we have to calculate the energy value as well as the kinetic energy value. What is the energy? Energy is equals to what? H nu. Energy is equals to what? H nu. And kinetic energy is equals to what? Half mv square. Is it possible to calculate the energy value? Yes. We know the H value and they have given the frequency of the incident light. Just substitute them 6.63. Nearly you take this one as a 6.63 into 10 to the power minus 34 into frequency. Frequency of the incident light is what? 8.14 into 10 to the power 14. So that you will get the energy 6.63 into 8.14. You calculate this one. Then 10 to the power minus 34 into 10 to the power plus 14. That is minus 34 plus 14. That is equals to into 10 to the power minus 20. Now 6.63 into 8.41. The value is 55.76. What is the value? 55.76. Use a simple calculator. Simple calculators are allowed in the examination. Energy is equals to 55.76 into 10 to the power minus 40 joule. Later what we need? We have to calculate the kinetic energy also. Kinetic energy is equals to what? Half mv square. Half mv square. M is what? Mass of the electron. V is what? Velocity or speed of the electron. Have they given the speed? Yes, they have given. Substitute those two. Half into mass value. What is the mass of the electron? 9.1 into, here they have given this mass of the electron 9.1 into 10 to the power minus 34. 31 into speed of the electron. This is the speed of the electron 7.5 into 10 to the power of 5 meter per second. You make this one as a square, v square. Now before multiplying the entire thing, first you calculate the 7.5 square. 9.12 into 9.1 into 10 to the power minus 31. 7.5 square, you make the answer 7.5 into 7.5. What is the value of the one? That is nearly 56.25. 56.25 into 7.5 square is nothing but 7.5 into 7.5. Next 10 to the power 5 whole to the power 2. That is nothing but 10 to the power 5 into 2. 10 to the power 5 into 2 is what? 10. That is 10 to the power 10. Now you simplify this one. That is the kinetic energy is equals to, first you make this one as the 9.1 into 56.25. 9.1 into 56.25. Calculate this one. Later divide the value with the 2. You will get nearly 255.94 into 10 to the power minus 31 plus 10 is the value minus 21. This is the kinetic energy. We got the kinetic energy and also energy. But what we have to calculate? Work function. Work function is equals to what? Work function is equals to energy minus kinetic energy of the photon electron. Now energy is equals to what? Substitute the value. Energy is equals to 55.76. 55.76 into 10 to the power minus 20. Okay, minus kinetic energy value. Kinetic energy. What is the value of kinetic energy here? 255.91 into 10 to the power minus 21. Can you make the exact only in terms of the 10 to the power minus 20? Yes, we can make. That will be 25.59 into 10 to the power minus 20. Okay, now that is 25.59 into 10 to the power minus 20. Here, out of these two, you take the 10 to the power minus 20 as the common. Remaining thing is what? 55.76 minus 25.59. If you simplify that, that is nearly 30.16 into 10 to the power minus 20. That is the value of the, this is the value of the work function. Just you take the 10 to the power minus 20 as the common out of these two. Remaining thing is what? 55.76 minus 25.59. The remaining value is 30.16 into 10 to the power minus 20. This is the work function. We got the work function in terms of the joule. Next, what we have to calculate? The second one is about the field. That is the threshold frequency. Threshold frequency is equals to question mark. Now we know the work function and we can calculate the threshold frequency. Work function is equals to h nu naught. From this one, nu naught is equals to, from this one, nu naught is equals to what? Nu naught is equals to work function divided by h. Substitute the work function value. This is work function value 30.16 into 10 to the power minus 20 divided by h value 6.63 into 10 to the power minus 34. Simplify this one. 30.16 divided by 6.63. 30.16 divided by 6.63. The value is 0.1. No. It is about 4.59. Just to simplify this one, 30 divided by 6, that is nearly 4.59. 4.59 into 10 to the power minus 20. If you take this one to the numerator, plus 34. 10 to the power minus 20 plus 34. Minus 20 plus 34. What is the remaining thing? That is plus 14. This is the 4.59 hertz. This is the threshold frequency. We got the threshold frequency value. We got the threshold frequency value. Here threshold frequency is that. Now we got the work function also. We have used the work function here in terms of the SN and H is also in terms of the SN. So that we got the threshold frequency in terms of the SN 4.59 10 to the power 14 hertz. If you want to make the as if you want to make this one in terms of the 10 to the power 15, it will be 0.459 into 10 to the power 15 hertz. But there is no problem. 4.59 into 10 to the power 14 hertz. This is the threshold frequency. Next, what we have to calculate? Work function already we have calculated, but we have to express it in terms of the electron volt. Joule into electron volt. Joule into electron volt. That is 30.16 into 10 to the power minus 20. Joule to electron volt means we have to divide, we have to multiply with the value of 1.6 into 10 to the power minus 19. We have to divide with the value of 1.6 into 10 to the power minus 19. Now 30.16 divided by 1.6. 30.16 divided by 1.6 into 10 to the power minus 20. If you take this one to the numerator, 10 to the power minus 19. Just you write the work function value in terms of the electron volt. Your value will be that is around 1.885. Your answer is around 1.885 electron volt. Okay. What we have to calculate this numerical? We have to calculate the work function as well as we have to calculate the threshold frequency. If you want to calculate the work function, we need the value of energy as well as the kinetic energy. Energy is equals to what? H nu. We have to calculate this one. Next, kinetic energy is equals to what? Kinetic energy is equals to half m v square. We have simplified this one. Later, work function is equals to energy minus work function. We have substituted this one. Later, threshold frequency is equals to, that is work function divided by h value. Substituted the work function value and substituted the h value, and we have simplified this one, and we got this here with 4.59 into 10 to the power 14 hertz. This is the threshold frequency value 4.59 into 10 to the power 14 hertz. Next, work function has to be expressed in terms of the electron volt. So that we have to divide this value with the charge on the electron, that is 1.6 into 10 to the power minus 19. Here 30.16 divided by 1.6, and you will get here with 1.885. Whatever the value is that you express it in terms of the electron volt. This is the third numerical. Next we will move to the fourth numerical. Next, question number 4. What they have given? A photon of wavelength 540 nanometer is incident on a metal surface of threshold wavelength 600 nanometer. They have given the wavelength of the incident photon. What is the one? 540 nanometer. Nano means 10 to the power minus 9. That is nanometer. 540 into 10 to the power minus 9 meter. Next, they have given the threshold wavelength. What is the threshold wavelength? Lambda naught is equals to 600 nanometer. 600 into 10 to the power minus 9 meter. Next, we have to calculate the maximum kinetic energy. What can we calculate? Maximum kinetic energy. Next, B, maximum velocity of the photoelectron. After the what we have to calculate? V max, maximum velocity of the photoelectron. Next, what we have to calculate? Stopping potential. That is V naught is equals to stopping potential is equals to what? And they have given H value along with they have given the mass of the electron. Now, first we are going to calculate the kinetic energy. Have you given the V value? No. Then we cannot use kinetic energy is equals to half mv square. We have to use the Einstein photoelectric equation only. What is the equation? Energy is equals to work function plus kinetic energy. From this one, what we have to calculate? Kinetic energy. What we have to calculate? Kinetic energy. I got these two later on, right? From this one, kinetic energy is equals to what? If you take this work function, it will be kinetic energy is equals to energy minus work function. Now, kinetic energy is equals to energy. Energy, have they given the energy value? No, they didn't give, but they have given energy value in terms of the wavelength. So that the energy is equals to what? hc by lambda. What function? Yes, hc by lambda. Now, have they given the lambda? Yes, they have given. Have they given the lambda? Yes, they have given. Now you can substitute these two values along with the hc. You can calculate the kinetic energy. First, we will do the simplification. H is the Planck's constant, that is the known value. C is the speed of the light. Just you take the hc as the common here. Is there anything? 1 by lambda minus 1 by lambda. Now hc, just keep the one hc until you simplify and have the term. That is 1 by lambda. Lambda value is what? That is wavelength of the incident photon. That is 540 into 10 to the power minus 9. Minus lambda naught threshold value. What is the value? 600 into 10 to the power minus 9. Now kinetic energy is equals to, here if you observe the two denominators, what is the common? 10 to the power minus 9. Along with the one, here 540 is the, here 600 is the, you can make this kinetic energy is equals to hc divided by, shall I take 60 as the common here? It will be easy to simplify. 60, if you take the 60 into 10 to the power minus 9, I have taken 10 to the power minus 9 as the common along with 60. 60 into 9, what is the sum? 540. So that you can make here 9. 60 into 9 is nothing but 540. 6 9 are 34 minus, here 600 is there. You have taken 60 as a common in the denominator. Is there anything? That is 10. 60 into 10, that is 600. Now hc divided by 60 into 10 to the power minus 9. 9 into 10, 90. 10 into 1, 10. Minus 1 into 9. Yes. This is the remaining thing, that is hc divided by 60 into 10 to the power minus 9. 10 minus 9 is 1. 1 divided by 90. Now simplify this one. That is hc, h value and c value. Here 60 into 90. 6 9 are 54. 60 into 90 means 5400 into 10 to the power minus 9. This is the kinetic energy. But we have to simplify this one. Now substitute the h value, c value, then simplify this one. H value is what? 6.63 into 10 to the power minus 34. Next, c value 3 into 10 to the power 8. That is speed of light divided by 5400 into 10 to the power minus 9. 10 to the power minus 9. Now simplify this one. 6.63 etc. power. First simplify the 6.63 into 3. 6.63 into 3. Later divide the result with the 5400 and you tell me that what the value you are going to get. 6.63 into 3 equals to, again later whatever the value you are getting, 6.63 into 3, that is nearly 19, you get 19 point something. Divided by again you divide the value with the 5400. Tell me the value. That is the value is nearly 0.003683 into 10 to the power. Now calculate the powers. 10 to the power minus 34 plus 8. If you take this one to the numerator plus 9. Now 0.003683 into minus 34. 9 plus 8, 17. Here minus 34 and plus 17. What is the remaining? 10 to the power minus 17. Now you can make this one in terms of the minus 19. If you make this one in terms of the kinetic energy, that is in terms of the minus 19, that it will be 0.3683 into 10 to the power minus 19. Now we got the kinetic energy. Next, what we have to calculate? Speed of the electron. Listen. Here, kinetic energy is equals to energy minus work function. Energy is equals to hc by lambda. Work function is equals to hc by lambda naught. hc is taken from 1 by lambda minus 1 by lambda naught. Then hc 1 by lambda value, again lambda naught value substituted, and when you do the simplification, we got the value kinetic energy is nearly equals to 0.3683 into 10 to the power minus 19 joule. Next, what we have to calculate? We have to calculate the maximum speed of the electron. Is it possible to calculate the maximum speed of the electron when you know the kinetic energy? Yes, it is possible to calculate the kinetic energy when you know the kinetic energy. You can calculate the speed of the electron. Yes. Now we will move to the speed of the electron. Now, kinetic energy over. Next, what we have to calculate? We have to calculate the speed. V max is equals to what? Kinetic energy is equals to half of mv square. From this one, you can make 2 into kinetic energy. If you take this one, this one will be 2 into kinetic energy divided by is equals to v square. But what do you need? V is equals to what? 2 into v is equals to what? Square root of 2 times of kinetic energy divided by mass of the electron. Now substitute the kinetic energy value, that is 2 into kinetic energy value. What is the kinetic energy you got here? What I said about 0.3683 into 10 to the power of minus 19 divided by m is what? Mass of the electron. That is 9.1 into 10 to the power of minus 31 kg. Now substitute the values are substituted already. Kinetic energy value, mass of the value. Then what we have to do? We have to do the simplification. 2 into 0.3683. You will get nearly 0.7 something. Again, whatever the value you want, divide that value into the 9.1. First 2 into 0.3683. Divide that value into the 9.1 and you write that value here. What is the value you are going to get? That is 0.08094 into, now 10 to the power of minus 19 is that. Take this value to the numerator. What it will be? Plus 31. The value will be is 0.8094 into 10 to the power minus 19 plus 31. That is about 10 to the power 12. Now you can make the one. Just express this one in terms of the 10 to the power 10. That is, it will be 8.094 into 10 to the power 10. Now simplify this one. Square root of 8.094 into square root of 10 to the power 10. What it will be? Square root of 8.094. Square root of 8.094. The value is 2.845. Into square root of 10 to the power 10. What is the one? 10 to the power 10. You can make this one square root and cancel 1 by 2. That is 2 1 2 5. So that your value will be 2.845 into 10 to the power 5. This is the V max. Maximum speed of the emitted electron is in terms of the 2 meter per second. That is 2.845 into 10 to the power 5 meter per second. This is about the maximum speed of the electron. This is over. Next, what we have to calculate? We have to calculate the stopping potential. Is there any relation between stopping potential and the kinetic energy? There is a direct relation. Stopping potential is equals to kinetic energy divided by charge on the electron. Kinetic energy value. Already we got what is the kinetic energy value you got here? That is 0.3683. 0.3683 0.3683 into 10 to the power minus 19 joule. Again, chart the character 1.6 into 10 to the power minus 19. 10 to the power minus 19, 10 to the power minus 19 gets cancelled. 0.3683 divided by 1.6. The value, just calculate the value. 0.3683 divided by 1.6. The value is about 0.23. 0.23. What is the estimate of the stopping potential? Volt. Stopping potential is equals to 0.23 volt. 0.23 volt. Now we got the stopping potential. In this numerical, we have calculated the maximum kinetic energy, next maximum speed of the electron, next stopping potential. Now I have completed the 4 numericals. Next numerical number 5 and numerical number 6. You solve them. Just first all of you watch all the numericals and you try to practice them. After practicing the 4 numericals, just you go for the 5th one and 6th one. The question number 5 and question number 6, they are similar to the previous numerical, so you can solve them.